Uh, so this is the second video for system of nonlinear ODEs. So my original equations were that dh1 over dt is nothing but minus c1 root h1 plus f1t, and the second ODE was dh2 dt is nothing but minus c2 root h2 plus c1 root h1 minus h2 plus f2t. And for implicit formulation I had h1n plus 1 is nothing but h1n plus delta t minus c1 root h1n plus 1 plus f1tn plus 1, and h2n plus 1 was nothing but h2n plus delta t minus c2 root h2n plus 1 plus c1 root h1n plus 1 minus h2n plus 1 plus f2t n plus 1. So this is my second equation. Now we will use the linearization thing. So as we remember that linearization of h1 n plus 1 will become h1 tilde plus 2 upon root h1 tilde h tilde minus h minus h1 tilde. That essentially means h1 n plus 1 is nothing but root h1 tilde plus plus 1 upon 2 root h1 tilde h1 minus root h1 tilde divided by 2. So essentially this becomes h1 n plus 1 h1 tilde divided by 2 plus 1 upon 2 root h1 tilde h1. Similarly, the term root h1 n plus 1 minus h2 n plus 1 will become will also become root of h1 tilde minus h2 tilde plus 1 upon 2 root h1 tilde minus h2 tilde and h1 n plus 1 minus h1 tilde h2 this is minus h2 n plus 1 minus h2 tilde. So I'll give you this expression again. So for the first part, root of h1 n plus 1 will become root of h1 tilde plus 1 upon 2 root h1 tilde h1 n plus 1 minus h1 tilde. The second expression will become h1 n plus 1 minus h2 n plus 1 is nothing but h1 tilde minus h2 tilde plus 1 upon 2 root h1 tilde minus h2 tilde, and this will become h1 n plus 1 minus h1 tilde minus h2 n plus 1 minus h2 tilde. So if I put the first expression in the discretized form of equation number 1, then equation number 1 says that h1 equation 1 says that h1 n plus 1 minus h1 n divided by del t is equal to minus c1 root of h1 n plus 1 plus f1 t n plus 1. So if I put this into this equation, then it becomes h1 n plus 1 is equal to 1 plus c1 delta t upon 2 root h1 tilde plus plus 0 times h2 n plus 1, since this does not have the coefficient of h2n plus 1 is equal to h1n minus c1 delta t root of h1 tilde upon 2 plus f1 t n plus 1. So the discretized form of first equation become that h1 n plus 1 1 plus c1 delta t upon 2 root h1 tilde plus 0 times h2n plus 1 is equal to h1n minus c1 delta t root of h1 tilde upon 2 plus f1 t n plus 1. Now from the second equation we have this thing, that is h2n plus 1 minus h2n divided by delta t is equal to minus c2 root of h2n plus 1 plus c1 root h1n plus 1 minus h2n plus 1 plus f2t n plus 1. And if I put the value of h2n plus 1 and this, then this equation becomes h2n plus 1 minus h2n divided by delta t is equal to minus c2 root of h2 tilde plus 1 upon 2 root h2 tilde h2n plus 1 minus h2 tilde plus c1 root of h1 tilde minus h2 tilde plus 1 upon 2 root h1 tilde minus h2 tilde h1n plus 1 minus h1 tilde minus h2n plus 1 minus h2 tilde. So this essentially gives that I have minus c1 delta t upon 2 root h1 tilde minus h2 tilde h1n plus 1 plus 1 plus c2 delta t upon 2 root h2 tilde plus c1 delta t upon 2 root h1 tilde minus h2 tilde h2n plus 1 is equal to h2n plus c1 delta t upon 2 root of h1 tilde minus h2 tilde minus c2 delta t root of h2 tilde divided by 2 plus f2t n plus 1. So this is coming from the second equation, and the first discretized form was that h1 n plus 1 1 plus c1 delta t upon 2 root h1 tilde plus 0 times h2 n plus 1 is equal to h1n minus c1 delta t root of h1 tilde upon 2 plus f1 t n plus 1. So this is by equation number 1. Now if I combine these two equations into the matrix form, then I have this system of equations: 1 plus c1 delta t upon 2 root h1 tilde and 0 minus c1 delta t upon 2 root h1 tilde minus h2 tilde 1 plus c2 delta t upon 2 root h2 tilde plus c1 delta t upon 2 root h1 tilde minus h2 tilde, and this is giving me h1n plus 1. h2n plus 1 is nothing but the RHS will have h1n minus c1 delta t root h1 tilde upon 2 plus f1 t n plus 1 h2n minus c2 delta t root h2 tilde upon 2 plus c1 delta t root h1 tilde minus h2 tilde upon 2 plus f2t n plus 1. So this bracket will be closed. So I have this system of a x is equal to b. So my initial guess for this thing will be h1 tilde and h2 tilde is nothing but h1n h2n, and we will keep updating h1 tilde h2 tilde is equal to h1 n plus 1 h2 n plus 1 till this is not divide sign, so h1 tilde will become h1 n plus 1, h2 tilde will become h2 n plus 1 after each iteration, and we will check for convergence, that is h1 n plus 1 minus h1 tilde should be less than 1 epsilon 1 and h2 n plus 1 minus h2 tilde should be less than epsilon 2. So these are my convergence criteria. So what essentially we are doing here, we are marching in time. Within time marching we are having iterations of linearization procedure. This is called Picard iteration type of approach or regular falsy type of approach. And if we got the convergence, yes, move to next step, no, loop within time step, continue. So this is the crux of nonlinear system of ODEs. We have talked about explicit formulation, implicit formulation, and in implicit formulation we talked about how Newton-Raphson approach is used. So within Newton-Raphson approach, since we are solving it for the system of equations, we will get a matrix system to be solved at each iteration, and then we talked about how linearization approach can be used to implicitly solve the nonlinear ODE. So we will basically nonlinearize the we will basically linearize the nonlinear terms and then form a matrix system Ax is equal to V. Then at each iteration we will keep solving this, and this is how we can solve the system of nonlinear ODEs. Thank you.